All right, so in this video, we are going to continue our work on inequalities, compound inequalities. Looks like the last problem that we worked on was an AND statement, part C in problem 3. Okay, so let's go ahead and continue. Let's take a look at another OR inequality, and then we'll look at AND again. So just to take a look at the different types of inequalities, the types of solutions that we might get, let's see. So let's go ahead and see what D has in store for us. So for part D, let's see, we already did A. We have x is less than 4, x is less than -4, or x is greater than or equal to 1. So if we get comfortable enough, we could try just drawing this on one single number line. Remember that the OR statement means that the solutions have to satisfy at least one of the inequalities. So x is less than -4 is drawn with an open circle and shaded to the left, or x is greater than or equal to +1, greater than or equal to gives us a closed circle and shading to the right. And so this is our graph. The interval notation goes as far left as -infinity up to, but not including -4. Or is the union symbol, and 1 to infinity. The 1 has a closed square bracket, and then the infinity has a parentheses. Infinity always has parentheses, beside it. Okay, so there's part D. That was not too bad at all. Let's see what else we can get. Let's go ahead and take a look at the other AND statement. We'll do it in black. Let's see what this one gives us. And this is where we can graph it as a single or multiple graphs. Let's see. So let me go back here just for a moment. And if you watched the previous video, you would have seen this problem here. X is greater than -2 and x is less than 5. So x is greater than -2. That is in interval notation, -2, comma, infinity. And you can see that there in purple. Or, sorry, and x is less than 5. X is less than 5 can be written in interval notation as -infinity to 5 with a parentheses after the 5. And so the way that we would, just like we wrote the union symbol earlier, there actually is a symbol for the AND statement as well. And it looks just like the union symbol, except it is flipped upside down. It is called the intersection. So it looks like this. It looks like an N kind of for AND or for intersection. And so that is just asking basically, rather than uniting the two interval notations and putting them together as, one bigger cluster, the intersection is just finding where these two sets intersect or, have values in common. And so the simplified version is this one here, from -2 to 5. Because what what numbers are larger than or equal to -2, but smaller than +5? Well, we can very clearly see that on the graph there. Larger than or equal to -2 is in purple, and smaller than 5 is in blue. Those two intersect exactly in that little region there. And so we can draw the interval, or we can write the interval notation as, just a simplified form here, -2 to 5 with a square bracket and put round parentheses on the other side. Okay, so the reason I say that is because for this next problem, let's go ahead and take a look at it in a couple different pieces here. X is greater than or equal to 6. So we'll put 6 here. X is greater than or equal to will be a closed circle. And to the right. And X is less than or equal to 2. 2 is here, less than or equal to, shades to the left. And so we could write the interval notation for each of these as -infinity, comma 2, including the 2, 6 to infinity, including the 6, and then we would need the intersection symbol between them. And so how do we simplify the intersection of these two sets? Well, that's like asking, look for any elements, any numbers that these two sets have in common. And in terms of the graph, look at the graph and just graph the intersection of the two shadings or the two, numbers that are selected there, the two sets that are drawn. And so here's the graph. The answer would actually be just an empty graph. 2, 6. Notice that those two shadings do not intersect. If you remember our hamburger and pizza example, we want both the pizza and the hamburger. I want a number that is greater than 6 or and less than 2. Is there a number that is smaller than 2 and bigger than 6? No, that's not possible. Right? That on the number line, that would be like asking for a number that's to the left of 2 and to the right of 6. And, that's not possible for a single number. And so there are no solutions to that compound inequality. No solution exists. And not only no solution there, but in terms of the set notation, we could use this 0 with a slash through it. That's called the empty set, meaning the solution set for this compound inequality is empty. There are no solutions. Okay, so that's a nice little example there. So cool. Let's go ahead and take a look at one final example. Oh, no, actually, I have to do two examples. I'm trying to make this video just so you can kind of see the different types of answers that are out there, the different types of problems that we might be able to do, and the different notations that will come up. And so one thing that's coming up here just now is this inequality here. It's actually not too complicated, but it's basically just a simpler way of writing an and inequality. This, in one way, can be very simple because it is just saying that x is between 0 and 6, where it can be equal to 6, but not equal to 0. And so we can just plot 0, we can plot 6. We can be equal to 6, but not 0. And so I'll just shade in between, and there you go. That's the answer. The interval notation is everything from 0 to 6, including 6, but not including 0. And yeah, that's basically it. Now, I did want to mention this only because this really, we can go further and just kind of say, well, this is really 0 is less than x, and x is less than or equal to 6. It's just a simpler way, a more compact way of writing that and compound inequality. And so we could even flip this inequality around and say x is greater than 0 and x is less than or equal to 6. And there you can just read it off. We need a number x that is greater than 0 and also less than or equal to 6. Okay, so if you graph these or shaded them independently, x is greater than 0 would have shaded actually very far to the right. Every number to the right of 0 is greater than 0. And if you also want something that is less than or equal to 6, then we would have shaded all the way to negative infinity to the left of 6. But since we have an and statement again, we need to find where those two shadings intersect, and that would be everything between 0 and 6, including 6, but not 0. Okay, so that's what that notation means. Very good. And don't forget to like the video, maybe leave a comment or subscribe to the channel to get updates for all my videos and potentially help me retire early. Okay, so let's go ahead and take a look at one more problem, and let's see if this one's good enough to be our last problem. X is less than or equal to, yeah, I'm going to do x is less than or equal to 5. So let's go ahead and blot that out here. X is less than or equal to 5, or x is greater than negative 2. So what does this look like? X is less than or equal to 5. So here's 5, less than or equal to, we'll put close circle and go in that direction. Or x is greater than negative 2. Negative 2 is here. That's an open circle, and greater than is shaded to the right. So what is the solution set here? And at any point, feel free to pause the video, try to write down an answer, what you think it might be, and then unpause the video to see if you're correct. Remember that for an or statement, we only have to satisfy one, or yeah, we only need to satisfy a minimum of one of the inequalities. We could satisfy them both, um, but we need at least one satisfied to be part of the solution set. And so notice that in a sense, in terms of the graph, we can say, well, which of the numbers are touched by one of the shadings at least one time? And it looks like all of the numbers are reached by this shading um, at least once. So, for example, the number negative 3, it is less than 5, so it satisfies one of the inequalities. Positive 6 is greater than negative 2, so it satisfies one of the inequalities. And we could say the numbers in here, like 0, this is like doubly a solution because 0 is less than 5, and it's also greater than negative 2. But it doesn't really matter, it doesn't get put on a better, footing or in a better position because it's a solution to both of the inequalities. We would just say it's a 0 is a solution just like 6 is for the compound inequality, but 0 actually satisfies both of the inequalities. Okay, so since all of the numbers get touched here, we would say the graph, we can't really simplify it. I mean, if you wanted to draw it a different way and just shade the whole thing, fine. But this shows here that we're shading everything. Um, yeah, if you wanted to graph it, we could put negative 2, positive 5, and then we'll just shade, to the right and to the left. Everything's included. The interval notation would be from negative infinity to positive infinity. Sometimes, we say all real numbers are solutions. And then sometimes you have this little nice R to show that. Okay, so that's the other kind of the last example there. There are different ways where these inequalities can be put together with or and to provide different solution sets, but I think we've seen a good, amount of examples to kind of help us through those. All right, so that's the end of this video. In the next video, we'll go over problem number 4. So, yeah, stay tuned for that one.